Hello, my name is Javier Stefan, and I will be presenting the future of wireless communication with ad hoc networks. So what are ad hoc networks? Ad hoc networks are self-organized wireless networks with no fixed base station, but instead using mobile nodes. Each of these mobile nodes in the network can work as a router to relay connection of data packets to their final destination, as well as enter or freely leave the network without informing other nodes and not destroying the wireless network infrastructure. So a little history of ad hoc networks. The start of ad hoc networks began in the early 1970s with the purpose of military demanding an arbitrary access to a shared radio channel using network nodes in the battlefield. Such experiment began with the knowledge of no existing network infrastructure available in the battlefield and the necessity of mobile network infrastructure to allow communication. 40 years later, ad hoc networks have been a potential candidate for advanced wireless communication networks. Potential applications are used in smart home automation systems, smart power grids, smart car transportation, and even hotspots. But it comes with one disadvantage, and the disadvantage is that the security of these networks, with so many untrusted nodes and entering and leaving the network, is very vulnerable. There are different types of ad hoc network setups. So first we're going to go over isolated ad hoc networks, which isolated ad hoc networks have no internet connection. So it's just a local network and can be classified into two scales, small and large scale. So we're going to go over large scale first. Large scale ad hoc networks should be developed and properly set up to maintain hundreds to thousands of portable nodes. But there's a limitation of data transmission between nodes. Large scale ad hoc networks is suited for the transmission of very important data where there are limitations of other network infrastructure, like a battlefield, to a disaster relief team or a vehicular network. Sadly, large isolated ad hoc networks do not have high potential for commercial because security, cost, and performance. On the other hand, small scale do have great potential. Small scale can be used for the automation home with smart appliances using wireless transmission, or in a presentation where the presenter wirelessly communicates their laptop to a projector. An integrated ad hoc network is another type of ad hoc network. It is very similar to isolated ad hoc network, but includes internet access with the use of routers. And the routers are specific ad hoc routers. So the way this system works is an ad hoc router broadcasted signal. Once it's broadcasting signal, mobile nodes start broadcasting a request from the gateway. If the mobile node is only one hop away, which is a direct communication with the gateway, it automatically connects to that gateway. But if there are multiple nodes, this is where it gets confusing. So the mobile node broadcasts the signal, searching for a gateway with its IP and MAC address. Once it's waiting for a response from one or multiple gateways in close proximity. The mobile node selects the path with the fewest amount of hops to a gateway and obtains an IP care of address. Once the care of address has been established, the node is currently transmitting to the gateway and generates an ad hoc IP packet, which is routed to the gateway using the ad hoc routing protocol. Once the gateway receives the packets, it removes the ad hoc routing header and forms a new packet to allow internet access. Another popular ad hoc network would be cellular. Cellular using cellular phones to expand coverage of the internet to other cellular phones and even service. Working just like the integrated ad hoc network, they will bounce off of each other to reach the final destination, which in cellular is a antenna. Vehicular ad hoc networks have a great potential for the future in vehicles and smart roads and smart cars. There are two types of applications for vehicular ad hoc networks. The safety application is the more original, the beginning of ad hoc networks. That's probably what we'll start seeing first. And the reason why is because the safety, obviously it's in the name, the application is for collision and obstacle avoidance, supportive driving, safety message and driving optimization, traffic optimization. It can help with a life critical circumstance. The luxury application has internet connection, which is the more difficult part. And the reason why it's more difficult is because, if a vehicle needs internet access, giving them a lot of applications in the vehicle like payment service or even location-based services It needs internet, so it's more of an integrated ad hoc network, or even a cellular ad hoc network. So now we're going to go over ad hoc attacks and security. There are many different types of attacks and security, and there's also prevention that we should take in consideration when developing these systems. Attacks on ad hoc network. We first classify the type of attacker. We have snoopers, pranksters, insiders, and malicious attackers. Snoopers would be the very broad classification of an attacker because it can be a nosy neighbor, a significant other, or even a parent, or even the government snooping. Like, it's just, privacy, and there has to be a bunch of regulations for that. Pranksters will have a malicious attempt to show off their hacking abilities to others and make a name for themselves. Insiders can be paid by others to upload infected software, so the attacker can have potential malicious attack on the ad hoc network. And the last classification of an attacker is a malicious attack. These are the most dangerous ones. These are the best hackers, and the sky's the limit for these guys, for these people, these hackers. The type of attacks these fellow attackers can create are denial of service, masquerade attack, man-in-the-middle attack, and even black hole attacks. But it does not stop there. There are so many potential attacks, and if a network system like this does hit the market, many new attacks would be also hitting the market daily. So security of ad hoc network types. First, there's authentication. That's where the node can authenticate the message it received is from a valid, legitimate sender, and the message is actually legitimate. Verification of data consistency, meaning that the message received compares to older messages and compares to make sure that it's very consistent. Privacy. It's when the node's privacy can be protected from the government and other observers, like snoopers. So privacy on ad hoc networks, it's probably what the market will request to make sure that their information is secured, etc. So the first thing is developers can use public and private key pairs because they are anonymous and does not contain any information related to the node. So it won't have information about the cellular phone as a node or a laptop, etc. And also, when you're using public and private key, let's say it's 128-bit, it takes very long to hack, and especially with today's technology. Maybe in the future it'll be done a lot faster, but as of today, it still takes too long. So public and private key is a great opportunity for privacy. We can also use digital signature, but this is used for large-scale isolated ad hoc networks, like vehicular network, vehicular ad hoc. And it's because there's no need for encryption. The only thing is that the node is receiving a safety message, and it acknowledges the sender's authentic and not a false sender using the digital signature. We can also use tamper-proof hardware, especially for the static gateways and the static nodes that are broadcasting the signal, and make sure that nobody can tamper with these hardware, as well as limit the personnel that have access, the authorized personnel that have access to these devices. And last, developers can set up different types of protocols, which protocols can have multiple routes to the final destination to make sure if one has been tampered or one has been hacked or attacked, there's still a way they can get to the final destination, and the final destination node be able to authenticate that is a valid information. There can also be routing headers, which routing headers, when the receiver receives when the receiving node receives the information, it will notice that there's a potential attack because there will be missing part of the header. Thank you for listening, and if you have any questions or concerns, please feel free to ask.